Hello and welcome to another Java tutorial. In this tutorial, I'm going to discuss how to set up a custom build tool for your Java project in Eclipse. And the reason that I like to discuss that because these days, like the people who are developing the JDK, right, the Java runtime, they are adding incubator features, the features that are not public yet, not accessible, but they have separate builds for those JDKs that have those features, and you can separately download those JDKs and then try to use them as your build tool for building your Java project, for compiling your Java files. And but the IDEs, for example, Eclipse IDE has its own compiler and it might not support those incubator features. For example, if I open my Java virtual machine folders, library Java, Java virtual machines, you see that I have a standard JDKs 11, 15, 16, JDK 8, but I also have JDK 14, but this is not the release version. This is a version that is has the project Valhalla in it. And if you're not familiar with what project Valhalla is, it's basically allows value type or inline classes, right? So what I want to do, I want to use these JDK as my build tool. So write classes that are actually value type classes which use the keyword inline before the keyword class, and then use the Java C here and the Java. These two, Java C and Java, they support basically the value type or inline classes. So I want to use these JDK, right? So the way I'm going to do it in Eclipse IDE, obviously working with Java C itself is not very easy because you have to pass the class path and tell it where the classes are, and that might not be a very easy thing to do. But the other easy thing to do here is to just set up a Maven project. So I'm going to right click project, Maven project, and then create a simple project, and then group ID test.valhalla, and then artifact ID test-valhalla, and then version doesn't matter, we want to package as jar. Let's finish, and it's going to create a Maven project, right, for us. And then what I'm going to do here is I'm going to basically this jdk14 is the only jdk14 that I have. So what I can do is go to the POM file of this Maven project. In the properties, I'm going to tell it maven.compiler.source14, and then maven.compiler compiler.target14. Okay. And if I save this and then update my Maven project, update projects, test Valhalla, okay, it automatically switches to Java SE14 runtime. Note that this is the JRE, this is the Java runtime, and it automatically sees my JDK14 Valhalla, right? So it automatically knows which Java runtime to use. Basically, when you after compiling your application, if you have a main method and you run it, it knows which Java executable to use, right? It uses the JDK14 Valhalla, which is correct. So this is my runtime. What about the build tool? What about the compile time? So what I'm going to do, obviously we're building with Maven, right? So let's create a class first. Let's create a package, test package, and then class, let's call it a complex number class, and I wanna make it an inline class. So this complex, so basically numbers, classes that represent numbers are very good candidates for inline classes because numbers don't really have and don't really need identities, right? So these are just numbers and we assume that they're immutables, right? So this is my class. So a complex number has a real part and imaginary part, and I just have a public constructor to initialize it, double real, double image. This dot real is real and this dot image is image, right? And then what I'm going to do, I'm going to also override the toString method. So source toString, and we're going to accept the default implementation by Eclipse, which is nice, right? And then I'm going to have a class, let's call it main, and we want to have a main method. And inside this main method, obviously, I'm going to instantiate a complex number. Let's call it Z1, new complex, and then 1.1, 2.2, and then sysout Z1. All right. So if I run this, everything works fine. So basically, so JDK4, so Eclipse, this version of Eclipse, this is the latest version, and it assumes JDK15. And so if I go back to run configuration in the arguments, you see that it tries to pass these show code details in exception messages, which I believe not supported by default in JDK14, so I'm going to remove it. And this constructs a complex number and prints it to the console. Now let's examine, so I want to examine the class type of this object, which is a complex number. So I want to say Z1. So we can do two-way, like the class, right? So let's see what this does. Class test.complex, right? So I want to say Z1.getClass. So let's so class test complex. These two basically give the same thing, but let's create another complex number here, Z2. So minus 1.1 minus 2.2. All right. And then I'm going to create an array, complex array. W is initialized with Z1 and Z2. All right. Now let's look at the w.getClass, right? So let's run this. So it says array, a square bracket means array, L semicolon means a Java object, an object that has identity, and this is the way the bytecode has been written for many years, right? L semicolon specifies a Java object. So in the bytecode, if you're not familiar, in the bytecode, the class type, the type of this complex array object is a square bracket, just for the a square bracket means array, and L semicolon, and inside that is the fully qualified name, which means package test.complex, right? So this is the actual type of these complex numbers, which is L test complex semicolon. Now with the introduction of this idea of a value type, a type that doesn't have identity, they had to kind of change it so that the JVM can differentiate between a object that has identity, which is the already L type, or the object that doesn't have identity. And they came up with the idea of Q semicolon. So if we somehow define this complex class as an inline class, a class that is a value type class, then this becomes test.complex. So, but it starts with Q instead of L, right, in the bytecode. But right now, what we're seeing here is that the actual class type is L semicolon, so this is not an inline class. And right now, currently, I'm building with Eclipse builder, right? So if I right click on my Eclipse project, go to properties and look at the builders, you see we're using a Java builder, and that's because the project nature is Java, and it also has a Maven nature, right? That's why it has a Java builder and Maven project builder. So both of these are allowed, but right now, as you type and save, Eclipse does incremental build using the Java builder, using the Eclipse compiler. On the other hand, I can build with Maven directly, right? So what this does is, if I open up a terminal and mvn -- version, let's see if I have installed Maven. Yes, so I have the latest version of Maven, and I'm using Homebrew to manage the versioning. And then my Java version is 16. It looks at this Java runtime, right? And then default, and then so basically what Maven does. So if I open up the terminal, so Java -- version. So I have Java 15 installed, and then what happens here is that basically Java 15 is on my path, right? That's why it finds it. And if I say Maven hyphen version, you see that it finds the Java 15 here. And but in Eclipse itself, it finds Java 16, which was installed from Homebrew, right? When I installed Maven, it also installed Homebrew. Now what I can do, I can say mvn. So I opened a terminal right at the project top level project, top folder. That's because that's where the POM file is. That's the home directory of my Maven project. And I can say mvn compile. And what it does, it says that compiling two sources, and then build successful, and then it puts them in this target, right? So we can either build with Eclipse as we type, or if we want to, for example, package it. So I can say mvn package, for example. So it tries to compile if something has changed, and then it creates the jar file and puts it here, right? So there's a manifest here, and these are my compiled classes. And Maven knows it has to set the compiler level to 14 because we tell it the source and target are 14, right? So the problem here is that if I add this inline class here, what happens here is that obviously Eclipse cannot build it because Eclipse compiler doesn't understand this. Even though it's using jdk14 or 15, doesn't matter, because this inline feature is not built into the compiler for the Eclipse. What about Maven? So if I say mvn compile, Maven is also going to fail. Actually, it succeeded. Interestingly, that's probably because that this class file didn't change. So let's see, mvn clean. Let's clean first, and then mvn. So let's clean up the terminal, clear, and then mvn compile. So this one failed, and it says that compilation failure in the complex.java class interface or enum expected. And we added this inline, which this doesn't understand. So because this is using the standard jdk14, so this is also not helpful for us. So what can we do? What we're going to do, we're going to remove I'm going to still use Maven for my build because that's very easy, but then I'm going to point it to jdk14 Valhalla, which has the Java compiler that understands the inline classes. So I'm going to remove these two builders from my Eclipse project. And then what I'm going to do, I'm actually going to create a new builder, which is an external program. So this program is it's Maven, and then but yeah, let's call it Maven or Maven-jdk14. The location is wherever my Maven is. So let me just run again, mvn version, and it tells me where the Maven home is, and the actual Maven executable is inside the bin, I believe, -bin, right? And then the working directory, what we're going to do, so obviously the working directory is where we execute the Maven command. So actually bin /mvn, right? This is our executable mvn. I can also check that. Let's bring back our terminal, cd here. Yes, it's inside the bin, right? This mvn executable is inside the bin. All right. And then the working directory is where the POM file is. That's where this executable should be executed in the command line. So we're going to use a variable which is the workspace location. All right. And What are the arguments? So we say mvn, and then we have to pass an argument. Let's say compile. We just want to compile. We can say clean compile, and then the refresh, let's not refresh anything, but then the environment. So Maven uses the JDK that Maven tries to search the JDK if it finds the Java home environment variable, right? So what I'm going to do, I'm going to define a Java home in this environment variable, and then let me bring back my content home. This home is where the Java home is. I'm going to copy it as a path name, and then go back to Eclipse, define my Java underscore home, and give it the value of jdk14. I'm going to replace it with whatever I have in my native. So, and I'm going to put this at the top. So one more thing that we want to do, we know that in Eclipse it has some sort of automatic build or incremental build, and Maven also knows incremental build. So what I'm going to do here is in the build options, we can allocate console, so we see the output. Right now I'm just selecting during the manual build, allocate console, and tell me what the output is. So okay. So let's see if I try to say let's try to run this main, and then class not found exception. So let's see if I go to terminal, I'm still here, mvn clean. All right, and then we want to build. So let's run this. So it showed the could not find or load main class test.main, and let's see. All right, I'm going to go back to our build tools, and then Maven jdk14. Basically, let's edit this, and workspace location, refresh the maybe also during the. So right now build failure requires a project to exit, but there is no POM in this directory. Okay, so the mistake that we made here, we set the working directory for workspace, which is not correct. It should be the project name, test. So the POM file is in the project name, so I'm going to say workspace and append to it. When you want to append to a Eclipse variable, you use colon and append to workspace location test-Valhalla. All right, so okay, apply and close. So right now it's building, and as you can see, build was successful. So and it understood inline because it searches for the Java home environment variable. If it's set, it looks for that particular Java build, which Java compiler and Java, right? So it uses that Java compiler that is specified by the Java home environment variable. And the nice thing about Eclipse is that you can set that environment variable for your build tool, and then actually replace it with whatever is in your system environment variable. So even if I have defined the Java home in my bash rc file, so that the command line and system can understand which Java to use, and it's set to Java 15, for this particular build tool, I'm telling it to replace that Java home with this jdk14 Valhalla. So when Maven runs, Maven looks for this Java home to see if we can find the Java on your operating system. And right now, when I run this Maven using this build command, it understands that it has to use the Java compiler which is inside this jdk14 Valhalla, not the one that system knows, right? Which is a good thing. The other thing is that we also set it to run and auto builds, right? Not only manual builds. Manual build is when you change something and then you go to a project and then build project. This is manual build. You're manually basically requesting a build, right? And right now there is nothing to build. So if I run this, you see there is nothing to build and it works fine. Now what I wanted to do that, so this is how you set up the external build, right? And then one thing to note here is that if we go back to our original main class and look at the outputs now, right now, as you can see, Eclipse still doesn't understand this, but it doesn't matter. We know that our project is building fine. The class files are correct because we're using the right Java compiler, or basically we're using the jdk14, which already has Valhalla included, so it understands inline classes. And again, if I run this, now you see the type of the classes has changed from class test.complex to inline class. And for the array, we have a square bracket that denotes array, but now we have Q semicolon instead of L semicolon, which means when this complex class is compiled, it has an identifier which is Q instead of L, right? Which means this is in fact a different type of object. It's a value type object, right? Now obviously we can do other things. For example, now if I change something, w0.get class, as soon as I save it, because I trigger an automatic build, it runs my build tool, which is this Maven. But I mean, printing to the console might not be the best option, as we want to kind of see. We don't want to see the output of the build each time it's building. So I can deallocate the console. Maybe I can also tell it to launch in background, right? So right now, as soon as I change something and save, it automatically runs in the background. And or maybe we don't really need to run in the background. So I'm going to edit, launch in background. Let's just remove it. So if I run this, as you can see, we have the complex class working fine, array working fine, and we are not Eclipse doesn't understand the inline keyword, but doesn't matter because we're not using Eclipse as a build tool. We're using an external JDK, and Maven knows how to use the right compiler using the Java home environment variable, and Eclipse provides a nice interface for replacing the system environment variable inside a sandbox. So this build tool, this interface is like a sandbox, and you can either replace whatever you define as environment variables here, replace the native ones. That's basically what we want to do with this. And then as soon as you change something, some changes, you save, it triggers an automatic build, which you don't really see. And Maven builds are relatively fast, so we don't feel the difference that much. But this is how we can use external build tools and use some incubator features such as inline classes. And now if one thing that we can look at is if I go back to Navigator and look at my class file, so target classes, and then if I open the complex class, we know that a value type class is, so it says that this class file was compiled from jdk15, and value type classes are final by default. So they are immutable. You cannot inherit from them because they don't have identity. They don't really have that kind of pointer type that JVM understands. And all the fields inside the a value type class, which is final, are also final. So you cannot have mutable inline classes. So they are immutable, all the fields are final. That's why you have to basically initialize them in the constructor, right? So you give up something like identity for which all the regular Java objects have, to go from L semicolon to Q semicolon identifier, and then you end up with inline classes that don't have identity. But the beauty here is that when you create array of these, they all have a flat layout in the memory. So inside the Java heap, this is actually a flat layout. I mean, it's not guaranteed, but at least it's something that JVM probably does, right? Most of the time. So basically, eventually JVM decides whether or not it's best to flatten these inline classes. And the model that they're using is that code like an object and then acts or works like a primitive. Primitives are flat layout. Like when you say int array, it creates a flat layout in the Java heap, right? However, object arrays by default are pointer arrays, right? So each element is a pointer that is pointing to a object somewhere in the Java heap, and chasing pointers is always not very efficient in general, right? That's why they try to come up with these inline classes. So this array has the layout of this complex array. If it's an inline class, is some header plus exactly all the real imaginary parts in order. So there is no array of pointers or references. So I hope you enjoyed this lecture and now have an understanding of how to play with these incubator features like inline classes, value type classes in Eclipse using Maven and external builds. So you can use your own build tool to compile the Java classes. All you have to do, you have to create a Maven project and then specify a Java home environment variable for your external build tool. I hope you enjoyed this. Please stay tuned, and I'll see you in the next one.